Alright, if you guys could please turn to the page in your notes that looks like this. 7.3, use similar right triangles. Okay. If the altitude is drawn to the hypotenuse of a right triangle, as shown here, then the two triangles formed are similar to the original triangle and to each other. So, this triangle, if you were to draw an altitude, that's a line perpendicular to the hypotenuse, this triangle is similar to this triangle, which is similar to the whole triangle. So, triangle CBD is similar to triangle ABC, triangle ACD is similar to triangle ABC, and CBD and ACD are also similar to each other. Alright, so for example, here's our triangle. You can redraw this. You can take this triangle. Here, let me color code it. You can take this triangle and turn it on its side, like so. You can also take this triangle. There we go. And then, of course, you have the big triangle. The big triangle, in order to make it work, you actually have to flip it over so that the right angle lines up with the other triangles. All three of these triangles inside this figure are similar to each other. So triangle FJG, triangle GJH, and triangle FGH. Make sure your letters are in the right places. Okay? Alright. I'd like you guys to do the same thing with this one. Notice that this one has the hypotenuse on the bottom. This one, the hypotenuse is at the top. So it's a little bit different, but I think you guys can do this. Okay? Let's go on to page 2. A cross-section of a group of seats at a stadium shows a drainage pipe, BD, that leads from the seats to the inside of the stadium. What is the length of the pipe? Okay, so this is what we have. We have this triangle and an altitude drawn like so. So first thing we have to do, we have to separate these triangles. I'm going to take this triangle and flip it around so it looks like this. This triangle I'm also going to flip around so the right angle is on the bottom. And then the big triangle is already lined up for us. So triangle ADB is similar to triangle BDC, which is similar to triangle ABC. So here is X. We could use this triangle and this triangle, or we could use this triangle and this triangle. The problem apparently wants us to use BDC and ABC. So that's this triangle and this triangle. BD corresponds with AB, and BC corresponds with AC. Now BD says here is X, AB is 20, BC is 30, and AC is 10 root 13. Okay? So I'm going to cross multiply. I've got 10 root 13x equals 600. I'm going to divide both sides by 10 root 13. 10 would make this like that. So 60 divided by root 13. I'm going to use a calculator. With this calculator, it looks like we'll have to do it this way. Square root of 13 is 3.60555 ish. So 60 divided by 3.60555, close enough, 16.64. So X is approximately 16.64. The length of the pipe is about 16.64 feet. Alright, you guys go ahead and try this one. Let's go on to page 3. Find the value of y. Write your answer in simplest radical form. Okay, so they're not looking for a decimal answer here. They want an exact answer. Okay. First thing, write a proportion. You know you have 3 similar triangles here. So the length of hypotenuse triangle FEG corresponds with the length of the hypotenuse of triangle FDE. That's the whole triangle. Okay? This equals the length of the shorter leg of triangle FDE. So the shorter leg would be here, which corresponds with the length of the shorter leg of triangle FEG. Okay, so the 2 triangles I'm using here, hopefully you guys can tell, triangle FDE and triangle FEG. I'm using the hypotenuse and I'm using the shorter leg of each triangle. Okay, this is a proportion. The length of the hypotenuse of triangle FDE is 15. The length of the hypotenuse of triangle FEG is y. The length of the shorter leg of FDE, that's the whole triangle, is y. The length of the shorter leg of FEG is 4. Okay, so here I can cross multiply. 15 times 4, that's 60. So 60 equals y squared. You take the square root. Root 60 equals y. 60, we already discussed, is 15 times 4. This is 3 times 5. 4 is 2 times 2. There are 2 2's. 3 and 5 don't have a pair, so I'm just going to leave the 15 in the square root because 3 times 5 is 15. Okay, and this is the simplest radical form. They don't want a decimal answer here. Alright, geometric mean. In a triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. The length of the altitude is the geometric mean of the segments, of the length of the 2 segments. So BD over CD equals CD over AD. Okay? Also, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse, and the segment of the hypotenuse that is adjacent to the leg. So AB over CB equals CB over DB. And AB over AC equals AC over AD. Alright, let's do an example. So, to find the clearance under an overpass, you need to find the height of a concrete support beam. You use a cardboard square to line up the top and bottom of the beam. Your friend measures the vertical distance from the ground to your eye and the distance, from you to the beam. Approximate the height of the beam. Okay, by theorem 7.6, you know that 6.9, the altitude of the given triangle, is the geometric mean of x and 5. Okay, now remember, the altitude divides the hypotenuse into 2 segments, and the altitude is the geometric mean of those 2 segments. So 6.9 is the geometric mean of this and this. Okay, so x over 6.9 equals 6.9 over 5. They didn't really give an in-between step. Let's cross multiply. We've got 5x equals 6.9 times 6.9. Let's pull out the calculator. 6.9, there we go, times 6.9. 47.61. If you divide both sides by 5. 9.522. I'm just going to leave it as 9.5. So the clearance under the overpass is 5 plus x, okay, because remember, you're looking for the whole thing. This is 5. X is 9.5. So the whole thing is going to be 14.5 because 5 plus 9.5 is 14.5, and this is in feet. Alright, I'll let you guys do the last two, and that's all.